Okay, so we're going to go through a bit of Chapter 3 review. Chapter 3 is stoichiometry, so this is the first of 4 videos to get us back in the stoichiometry mindset. So the very first video is going to be about balancing chemical reactions. In this chapter, all we're doing is studying chemical reactions. So the first things first, we got to understand how to write the reactions and then how to balance it so we can conserve mass. So with that, we've learned about synthesis reactions, decomposition, single replacement, double replacement, and combustion. And so this will be a review of how to write and balance them. So for example, the first problem you can have is sodium undergoes a synthesis reaction with chlorine gas. So if you remember from class, synthesis is when two things come together to form one thing. So our example was A plus B turns into C. So what we're going to have here is we're going to have sodium reacting with chlorine gas. So what we need to do is we need to start with the symbol for sodium. Sodium is Na. And we're going to react that with chlorine gas. Chlorine is a special element because it's a diatomic element. So the way you remember this is have no fear, ice cold, root beer. So chlorine is the Cl from cold. What that means is when you write it, you're always going to put that 2 down there if it's alone. So what's going to happen is these two atoms are going to come together to form a compound. So A and B are going to come together to form C. So to figure out what C is, what you need to do is you need to crisscross the charges of both of these atoms. So we know that Na is in group 1, so it has a charge of +1. Chlorine is a halogen, so it's in group 17, it has a charge of -1. So when you crisscross that, you get NaCl. So now your very next step is to list off each atom and how many there are. This will help us see if we need to balance it at all. So on the left-hand side, I have 1 sodium, but I have 2 chlorines. On the right-hand side, I have 1 sodium, 1 chlorine. So we are not balanced because chlorine doesn't match. Now you can't change any of the little numbers. All you can do is add coefficients. So what I'll notice is I have 2 chlorines on the left, so to balance it, I'm going to put 2 on the right. What that does is that changes this to a 2, but it also changes sodium to a 2. So to fix that, I'm going to put a 2 in front of sodium right there. All right, now we have another kind of reaction. So we have copper reacting with silver nitrate to form silver and copper 2 nitrate. So first things first, we want to write out the formulas for each of these chemicals involved. So we have copper. Copper is Cu. And it's reacting with silver nitrate. Silver nitrate's a compound, so we need to crisscross to figure out what that is. Silver is Ag, and it always has a charge of +1. Nitrate is NO3-. It is on page 2 of your reference table. So when you crisscross that, you get AgNO3. Now, generally, when you have a metal reacting with a compound, you know that this is a single replacement reaction. What's nice about this problem is I told you what's going to form. So we have silver. So silver is Ag. And then we have copper 2 nitrate. So that means the charge for copper that I'm going to crisscross with nitrate is going to be a +2. Nitrate is still NO3-. So when we crisscross that, we get CuNO3. 2. So now we want to list off each atom so we can balance this out. So we have copper, we have silver, and for my polyatomic ions, I'm going to keep them completely together. It'll make balancing a lot easier. And now I'm simply going to count how many there are. So on the left-hand side, I have 1 copper, 1 silver, and 1 nitrate. On the right-hand side, I still have 1 copper, I have 1 silver, but I have 2 nitrates. So I'm going to go to the left-hand side, and I'm going to put a coefficient of 2 right in front of this compound, because that'll change my nitrate to 2. Unfortunately, it changes silver as well. So now we have 2 silvers on the left, 1 on the right, so I have to put a 2 right here. And once all your numbers match, you've balanced the reaction. So last but not least, we have a combustion reaction. A combustion reaction is when you have a hydrocarbon reacting with oxygen gas to form carbon dioxide and water. So first things first, we have to figure out what methane is. So because it's organic, the name for the hydrocarbon is going to tell you how to figure out the chemical formula. So in chemistry, Meth is going to mean 1 carbon, so we're going to start with C1. ANE tells us we're going to multiply the number of carbons by 2 and add 2, so you get 1 times 2 is 2, plus 2 is 4, and this is also in your reference table if you forgot that formula. So what we're going to do is we're going to add that to oxygen gas, because fire cannot happen without oxygen, and then we're going to form carbon dioxide and water. So our very next step is to figure out if this is balanced. So I'm going to list off each atom and how many I have. I see 1 carbon, 4 hydrogens, and 2 oxygens. On the right hand side we have CHO. I have 1 carbon, 2 hydrogens, but I have 3 oxygens because there's 2 right here and 1 right here. So now what I got to do is I got to start making these things match. I'm going to leave oxygen till the very end because it'll make my life easier. So carbon is good, but I see I have 4 hydrogens and only 2 on the right hand side. So I'm going to put a 2 right here because this 2 times this 2 means I have 4 hydrogens. What that's also going to change is it's going to change the amount of oxygens I have. So I have 2 right here, but now I have 2 right here. So I now have 4 oxygens on the right, which is good that that's an even number because I'm stuck with this O2. So I have to figure out what times 2 gives me 4. So we'll throw a 2 right there, change that to 4, and we're now balanced.